welcome back to my YouTube channel. So today in this video we'll be discussing about the image formation by a concave mirror. So we know that a concave mirror, which is also called as a converging mirror, forms real and inverted images. So for different position of the object, today we'll find out the position of the image, nature of the image and the size of the image. But before we go to the image formation, we need to learn the rules. So we have few rules to remember, and with the help of the rules we can form the image by a concave mirror. So before we do the image formation by a concave mirror, we must know the rules. So there are three rules to remember, and if you know the rules, then we can easily do the image formation. So let's start with the rules for image formation. So rule number 1, it says that if the incident ray is parallel with the principal axis, then the reflected ray must pass through the focus F, capital F. So here in the diagram, you can see we have a concave mirror. So this is the center of the mirror, which is called as the pole, and this point is our center of curvature. And between pole and center of curvature, we have this point, which is called as the focus. We have already discussed about various terms in the previous videos, so you can just check the video and you can know the terms. So let's come back to the rule here. So here we have this incident ray. So the incident ray is the ray which is coming towards the mirror. So this incident ray, as you can see, is parallel with this principal axis. So principal axis is the line which passes through the center of curvature and the pole. So our incident ray is parallel with this principal axis, and the rule says that after reflection from the mirror, it must pass through the focus F. So this point is the focus F here. So after reflection, it passes through the focus. So here you can see the statement: if the incident ray is parallel with the principal axis, then the reflected ray passes through the focus. So this is rule number 1. Rule number 2. Rule number 2, it says that if the incident ray passes through the focus, then after reflection, it becomes parallel with the principal axis. It is just the reverse of the first rule. So here in the diagram, you can see we have this incident ray which is now passing through the focus F. So the incident ray is passing through the focus F, and as soon as it strikes the mirror, it reflects. So the reflected ray, you can see, becomes parallel with this principal axis. So the statement, if the incident ray passes through the focus F, then the reflected ray becomes parallel with the principal axis. So this is just the reverse of the first rule, which says that if the incident ray is parallel, then reflected ray passes through the focus. So the rule number 2 is just opposite. If the incident ray is passing through the focus, then reflected ray becomes parallel with the principal axis. Now rule number 3. Rule number 3, it says that if our incident ray is passing through the center of curvature, then the reflected ray, that is the ray after reflection, retraces the path. Now retrace means to follow the same path backwards. So in this diagram you can see, so this incident ray that we have is now passing through this center of curvature. This point is focus F. So this incident ray is now passing through the center of curvature. Now once this incident ray strikes the mirror, after it becomes incident, it gets reflected back. So after reflection, it will follow the same path in the opposite direction. That means it will follow the same path backward. That is the meaning of retrace. So the statement you can see, if the incident ray passes through the center of curvature, which is capital letter C, then the reflected ray retraces the path. Retrace means to follow the same path in the backward direction or in the opposite direction. So this is rule number 3. Okay, so let's revise the 3 rules again. So rule number 1, it says that if the incident ray is parallel with the principal axis, then reflected ray will pass through the focus F. Incident ray parallel with the principal axis, the reflected ray is always passing through the focus. Just the reverse, rule number 2, if the incident ray is passing through the focus of the concave mirror, then reflected ray will become parallel with our principal axis. You can see that rule number 1 and rule number 2 is just the reverse or opposite of one another. And rule number 3, it says that if the incident ray passes through the center of curvature, then the reflected ray will retrace the path. Retrace means follow the same path in the backward direction or the opposite direction. So if you remember these 3 rules, then we can do the image formation by a concave mirror. So for image formation, we need at least 2 rays. Alright, so out of these 3, we can use any 2 to form the image by a concave mirror at different positions. So now let's discuss the image formation by a concave mirror for different positions of the object. Okay, so the first case that we are doing is when we have an object at infinity. So infinity means a very large distance. So whenever an object is at infinity, we must know that the incident ray will always fall parallel to the principal axis. So here we have the first case. We are keeping the object at infinity. So we have a concave mirror having pole, the center of the mirror, we have the focus, and we have center of curvature. And we are taking that object is at infinity. So as I said, whenever we say object is at infinity, then we can consider the incident ray parallel with the principal axis. So for image formation, we need at least 2 rays. Okay, so we will follow the rules and we will see where the image will be formed. So we have to find 3 information here. We will find out the position of the image, where will be the image formed, next what will be the nature of the image formed, and the third one, what will be the size of the image as compared to the size of the object. So for that, since object is at infinity, so we will consider or we will take the incident rays parallel to the principal axis. So this is the first incident ray which is parallel to the principal axis, and we are taking second ray that is also parallel with the principal axis. Now why we are taking 2 incident rays? Simply because in order to form the image, we need 2 rays where they will intersect. So at that point the image is formed. Now we will follow rule number 1. Since these incident rays are parallel with this principal axis, we will follow rule number 1, which says that whenever incident ray is parallel with the principal axis, then reflected ray must pass through the focus. So these incident rays after reflection will pass through this point which is called as our focus. So this will be the first reflected ray passing through the focus, and this will be the second reflected ray passing through the focus. So we have simply followed rule number 1, which says if the incident ray is parallel with the principal axis, reflected ray will pass through the focus. So here we can see that these 2 reflected rays, are intersecting at the point F. And wherever these reflected rays are intersecting with each other, we get the image of an object, right? So here, since the reflected rays are actually intersecting with one another, the image formed is called as the real image. So there can be 2 types of image formed, real image and the virtual image. Now real images are formed when reflected rays actually intersect with each other, and virtual images are formed when reflected rays are produced backwards. So when we discuss convex mirror, there we will see how virtual image is formed, or in concave mirror also in the last case we will see how virtual image is formed or what is a virtual image. So here you have to understand that since the reflected rays are actually intersecting at the point F, the image formed will be real, and concave mirror forms real and inverted image. Real images are always inverted. So here one you can feel is nature of the image. So nature will be real and real images are always inverted. So you can write real image and inverted image. Now if you look at the position of the image, where is the image formed? We can see that the reflected rays, they are actually meeting at the point F. So at point F only we will have the image of the object which is kept at infinity. So position of the image will be exactly at capital F, that is focus, and size of the image. So since the 2 reflected rays are intersecting at a point, so the size of the image will be highly diminished, or we can say a point size image is formed. So either you can write highly diminished, or you can write point size image is formed. So whenever our object is at infinity, object at infinity means incident rays will be parallel with the principal axis. So we need to draw 2 incident rays. So after reflection, the incident rays will pass to the focus according to rule number 1, and wherever the reflected rays are intersecting, image is formed. And since the image is formed due to actual intersection of the reflected rays, image we can call it as real, and real images are always inverted. Here it will be point size, but real images are always inverted. So we can write real and inverted here. Now position of the image is at F because the two reflected rays intersect at the point F. And thirdly, size of the image, it will be highly diminished, or we can say that a point size image is formed. So this is case number 1. So in the second case, we are keeping the object beyond C. So the object here will be beyond C, behind C, that is center of curvature. So let's see what happens or what kind of image will be formed when the object is kept beyond C, that is center of curvature. So again here we will follow the same thing. We will need two incident rays coming from the object, and we will see where the reflected rays will intersect. So we will use the first rule, that is, so this one is our object, as you can see, and this object is kept beyond C. Behind C we have this object. Now from object we will consider two incident rays. One incident ray we will consider parallel with the principal axis. So this is the first incident ray, and this first incident ray is parallel with the principal axis here. Now the rule says if the incident ray is parallel with the principal axis, then after reflection it must pass through the focus. So this reflected ray here will pass through the point F, that is our focus. So for this first incident ray, which is parallel to the principal axis, after reflection the reflected ray is passing through the focus F. So here we have used rule number 1. Now we need the second ray so that we can see where the reflected rays will intersect. So for that we will use rule number 3, which says that if the incident ray passes through the center of curvature, then the reflected ray will retrace the path, right? So let's consider another ray coming from the object, and let's say that the incident ray here passes through the center of curvature like this. So as the incident ray passes through the center of curvature here, so this one is the incident ray that is passing to the point C. After reflection, the rule says it retraces the path. It follows the same path in the opposite direction. So we have two reflected rays, one passing through this focus F going in this direction, and the other one retracing the path in this direction. So these two reflected rays, as you can see, intersect at this particular point. So wherever the rays intersect, what we have to simply do is we have to draw a perpendicular line here. So this will be the image of the object, right? So image is formed here, and as you can see the image will be inverted because concave mirror forms real and inverted image. So now let's fill the details here. Position of the image, where is the image formed? As you can clearly see, the image is formed between focus F and center of curvature C. So here you will write it is formed between, you can use the symbol only, no need to write it, the words itself, focus and the center of curvature, that is C. So our image is formed between focus and center of curvature here. Now look at the second term, nature of the image. As this image is formed due to actual intersection of the reflected rays, we call it as real image, and real images are inverted images. So here again we will write the nature, real and inverted. Now the third thing is the size of the image. If you compare the size of the object and the size of the image, you will see that the size of the image is smaller than the size of the object. So we call it as diminished, which has become smaller. So here we can write the image size is diminished. So whenever we have the object beyond C, then the image formed will be between focus and center of curvature. The size of the image will be diminished and the nature of the image will be real and inverted. So to form the image, we have used two rules here. One, incident ray parallel to the principal axis passes through the focus. And the second rule we have used here, incident ray passing to the center of curvature will retrace the path. And wherever the rays, that is reflected rays, intersect, from there you have to drop the perpendicular on the principal axis, and this will be the image of the given object. So this is the second case. So this is the third case that we are doing. Here we have the object at center of curvature C. So this is the third case, object at C. So you can see this is a concave mirror. We have the pole, focus and center of curvature. Now in this case, we have an object which is placed exactly at the center of curvature. So this is our object. Now let's use the rules and see what kind of image will be formed, where will be the image formed, and what will be the size of the image. So for that, again, we will use the rules that we have learned. So we will use two rules here again. The first rule that we will use is incident rays or incident ray which is parallel with the principal axis. So from the object, we need to draw two incident rays, for which there will be two reflected rays, and wherever the reflected rays intersect, we get the image. So this is the first incident ray, and the incident ray, as you can see, is parallel with the principal axis here. So the rule says if the incident ray is parallel with the principal axis, after reflection, it passes through the focus. So here you can draw the reflected ray which is passing through F. So this is following rule number 1. So this is the reflected ray that is passing through the focus F. Now we need another incident ray. So for that, we will consider a ray which is going, or a ray which is passing through the focus F. So the second incident ray that we are taking here, this one, is the ray which is passing through the focus F. Now the rule says if the incident ray is passing through the focus, then the reflected ray will become parallel with the principal axis. So as this ray gets reflected from the mirror, the reflected ray will go in this direction. So if you use sharp pencil and draw the diagram properly, you will exactly get the position of the image. Alright, so this incident ray is passing through the focus, and after reflection, it becomes parallel with the principal axis. So which two rules we have used here? The first one is parallel with the principal axis. After reflection, it passes through the focus. The second rule that we have used is if incident ray passes through the focus, reflected ray becomes parallel with the principal axis. So wherever the reflected rays intersect, we will get the image of this object. And from there, what we have to do? We simply have to drop a perpendicular on the principal axis. From wherever the two reflected rays are intersecting, just drop a perpendicular on the principal axis, and that will become the image of the object here. So by following the rules, we have followed or used two rules, and we have obtained the image here. So if you look at the position of the image is formed exactly at C. So here you can write down image is formed at the center of curvature C. Now if you look at the nature of the image, as it is a concave mirror, the reflected rays are actually intersecting. So this will be also real and inverted image. And the third thing here you can see is size of the image. Now if you look at the size of the object and the size of the image, in this case both will be same. So you can write the size of the image will be same as the object. So here object size and image size will remain same. So this is case number 3. When an object is kept at C, we will get the image at C. Image will be real and inverted, and size of the image and the size of the object will be same. Now this is case number 4, where we have an object here between C and F, that is center of curvature and the focus. So case number 4, object between C and F. So here we have kept this object between the focus and the center of curvature. So let's see what kind of image will be formed here, where will be the image formed, and the size of the image. So for that again we will use the rules. So the first incident ray we will consider parallel to the principal axis. So if you know the 3 rules, you can do all the image formation. So the rules are very important. So as you can see, we have taken this incident ray parallel to the principal axis. Now the rule says, if the incident ray is parallel to the principal axis, reflected ray must pass through the focus. So after reflection, this ray will travel through the focus like this. So this is your reflected ray which is passing through the focus. So we have one incident ray which is parallel to the principal axis, after reflection passes through the focus. Now we need the second incident ray. So the second incident ray we will consider passing through the focus here. So from the object we need another incident ray which is passing, let's say, through the focus. So this is the second incident ray that we have drawn, and the second incident ray from the object is passing through the focus. Now the rule says, if the incident ray passes through the focus, then reflected ray becomes parallel with the principal axis. So let's draw the reflected ray here. So this reflected ray will become parallel with the principal axis. So this is the incident ray and this is the reflected ray. So you can see that the 2 reflected rays are intersecting at this particular point. So this is the first reflected ray going in this direction, and this is the second reflected ray coming in this direction. So the 2 reflected rays intersect here. So wherever the reflected rays intersect, there we will get the image. So next thing you will do is you simply draw a perpendicular on the principal axis, and this will become the image of the given object. So here you have seen that we have used 2 rules, one parallel to the principal axis, second passing through the focus, the incident ray. The one which is parallel to the principal axis passes to the focus after reflection. The one which is passing to the focus after reflection becomes parallel with the principal axis. The 2 rays will intersect here and we will get the image. Now let's see the position of the image. Now if you can see the image, it is formed beyond C or behind C. So you will write here, position of the image is formed beyond the center of curvature C. If you look at the image, again the reflected rays are intersecting each other, so it is real image, and real images are always inverted images. So we can write real and inverted here. And the third thing, size of the image. Now if you look at the size of the image and the size of the object, then the size of the image is greater than the size of the object. That means the image has been magnified. So here we will write the image is magnified. So whenever an object is kept between C and F, we get image beyond C. It will be real and inverted, and the size of the image will be magnified. So this is case number 4. So let's see the next case where an object is kept at focus. So this is case number 5, object at focus F. So we have an object kept exactly at the focus F here in front of a concave mirror. So let's see what will be the position of the image, nature of the image, and size of the image when our object is at focus. So again we will take 2 incident rays following 2 rules. So the first rule, if the incident ray is parallel with the principal axis. So here we have taken that the incident ray is parallel with the principal axis. According to the rule, this ray after reflection will pass through the focus. So we can draw the reflected ray passing through the focus here. So we are using the same rule again and again, so it will be easy for you to remember. So rule number 1 we have used. If the incident ray is parallel with the principal axis here, the reflected ray will pass through the focus. So this is rule number 1. Now we need second incident ray from the object, but here we can use the rule 3, which says that if the incident ray passes through the center of curvature, but here we will see that the ray which is going towards the mirror, after reflection it retraces the path. So we will consider a ray of light going in this direction from the object. So from this object our incident ray is going in this direction, such that after reflection it will retrace the path. Alright, so after this reflected ray retraces the path, it will go in this direction. So let's extend this line further. So this is same rule number 3, which says that if the incident ray is passing to the center of curvature, then the reflected ray retraces the path. So our incident ray from the object is going in this direction, and after reflection it is retracing the path and exactly passing to the center of curvature. So here we can see that we have two reflected rays here, but these two reflected rays, they are parallel to each other. That means they are not intersecting at this particular point. But what we will consider is that parallel rays, they intersect far at infinity. So we will take into consideration that these two rays will also intersect at infinity. Alright, so here the image that will be formed, the position of the image, you can write it at infinity. Why we are writing it at infinity? Because the reflected rays, they are parallel to each other, and parallel rays we consider that they will intersect at infinity. So image is formed at infinity wherever they intersect. Now if you look at the nature of the image, since we are considering that the two rays will intersect each other at infinity, so image formed should be real and inverted here. Now if you look at the size of the image, it will be very large in size as compared to the object. So here you can write the size of the image will be highly magnified. So wherever we have object at focus, then image is formed at infinity, nature will be real and inverted, and size of the image will be highly magnified. So this is the 5th case that we have done. So this is the last case for image formation by a concave mirror, and this one is interesting and it is also important because this is the only case where a concave mirror forms virtual image. Okay, so the last topic that we have is object between pole and the focus. So here you can see we have kept an object which is between the pole and the focus of a concave mirror. Now in order to form the image, again we will follow the same method. We need two incident rays for which we will have two reflected rays, and depending on whether the reflected rays intersect or appears to intersect when produced backward, we have the image formed. So let's see what kind of image is formed here. So from the object we need two incident rays. So for that we will follow the first rule, taking incident ray parallel to the principal axis. So this is the first incident ray which is kept parallel or which is parallel with this principal axis. Now the rule says if the incident ray is parallel with the principal axis, after reflection it passes through the focus. So let's draw the reflected ray here, and according to the rule the reflected ray must pass through the focus here. So we have this reflected ray which is passing through the focus. Alright, so incident ray is parallel, reflected ray is passing through this point which is called as the focus F. Now we need the second incident ray, but for the second incident ray we cannot take it passing to the focus because the object is between focus and the pole. So here we will use the third rule which says that if the incident ray is passing to the center of curvature, it will retrace the path. So here we will draw the incident ray in such a way that after reflection it will retrace the path. So we have this incident ray going in this direction, right? So the incident ray is going in this direction. Now after reflection it will retrace the path. So after it retraces or it goes backwards, it passes through the center of curvature itself. Alright. So this is the incident ray which is going in this direction, and after reflection it retraces the path. It follows the path backward. So we have two reflected rays going in this direction. So these two reflected rays, as you can see, they are not going to intersect anywhere because they are not parallel to each other. If they were parallel, then we could have said that they will intersect at infinity. But these two rays are not parallel with each other. They are diverging further, going apart from each other. So in order to form the image, here what we will do is, we will produce these rays backwards. We will draw these rays in the opposite direction, that is backwards. So let's produce the reflected rays backwards. So when we produce this reflected ray backward, then the first reflected ray will come in this direction, and the second reflected ray, it will come in this direction. So when we produce this reflected rays backwards, when we drew the diagram or do the drawing in the opposite direction or produce them backwards, we put it backwards, then they are going to intersect at some point. And wherever the two rays after producing backwards intersect, there we will get the image of the object. So from here, you can draw the perpendicular on the principal axis. So this now becomes the image of this object. So here, as you can see, the image formed is not due to the actual intersection of the reflected rays. Rather, the image formed here is when these reflected rays are produced backwards. So this kind of image which is formed when reflected rays are produced backwards, when the reflected rays does not actually intersect with each other, we call this kind of image as virtual image. And as you can see, the virtual image is always erect. It is formed behind the mirror. So the image formed by a plane mirror, it is also virtual, and whenever you look at the image, it is always erect, and it will be behind the mirror, right? So position of the image, here you can write, it will be formed, instead of beyond, you can write behind the mirror. Next, nature of the image, as I said, behind the mirror we have a virtual image, and virtual image is always erect image, and size of the image, you can see it is highly magnified, or you can simply write magnified also. So this is the only case where a concave mirror forms a virtual, erect and magnified image. Otherwise, concave mirror always forms real and inverted image. So this one is a special case, so that's why this is important. You may get question based on this as well. Okay, so that's all from today's topic. So we have learned about the rules for image formation by concave mirror, and we have discussed 6 different cases where object is placed at different positions and we are getting the images of that particular object. Alright, so from here you may get, or you will definitely get questions, so you can prepare this topic well. And that's all for today. Do like, share and subscribe my channel, and hit the bell icon for further notifications. Thank you everyone.